Okay, now that we know how to handle multiplying exponential numbers, we can talk about multiplying polynomials. So if I'm just multiplying a monomial and any other length polynomial, that's nothing new. Everything in it we've done because we'll just do the distributive property, right? The only difference is now we may have exponential values that we'll have to multiply other than just numerals or a single x times a number. But I'm still just gonna, first of all, get a pen. I'm still just gonna take this 5x squared and distribute it through this binomial. So 5 times 6 is 30. And then an x squared times an x to the fourth, since I'm multiplying exponential numbers that have the same base, you add the exponents. Here's two of them being multiplied together, and then I'm going to multiply that times 4 more. So x to the sixth. And then 5 times 7, positive 7, is positive 35. And there's not another variable term, so I just keep that times x squared. If I could simplify this, I would, but these are not like terms, so I can't combine them. Same thing here, except I'm going to distribute this term times every term in the trinomial. Okay, so negative 2 times negative 3 is positive 6. H to the fourth times h to the ninth, 4 plus 9 is 13. Negative 2 times positive 8, negative 16. H to the fourth times h squared, 4 plus 2 is 6, so h to the sixth. And then finally, just times negative 1, so that'll be positive 2h to the fourth. Okay, so notice what we did. We just multiply this term times every term in the polynomial, right? However many terms there are. We're just going to make sure we multiply that monomial times every term in the polynomial. Okay, so if we're going to multiply something besides a monomial, all we do is multiply each term in that polynomial times every term in the next polynomial. For example, if I'm going to multiply a binomial times a trinomial, I'm just going to multiply this 2y squared times every one of those, just like we just did. And then it doesn't matter how many there are. I'll multiply it all the way across. And when I'm finished, I'll move to this term and multiply it all the way across, however many terms there are. If there was another term in here, then I would go to the next term and multiply it all the way across. That's all there is to multiplying polynomials. So let's start right here. So we have 2 times 2 is 4. Y squared times y cubed. 2 plus 3 is 5. So that's 5 y's now getting multiplied together. Okay. 2 times negative 7 is negative 14. And a y squared times one more y would be 3 y's being multiplied together. 2y squared times 4. So 2 times 4 is 8 times y squared. Okay, now that I've multiplied this by every term, I jump to the next one and do it. Negative 5 times 2 is negative 10 y cubed. Negative 5 times negative 7 is positive 35 y. Negative 5 times 4 is negative 20. Once I've multiplied it by every term, if there was another term in my first polynomial, I would jump to it and do the same thing. But there's not, so I'm finished. Now I just have to see if there are any of these terms that are alike. So that's a y to the fifth. There's not any other y to the fifth. Okay, here's a y cubed. Oh, and here's a y cubed. So negative 14 minus 10, that's negative 24 of those y cubed things. Remember, when we're adding, exponents don't change. right? I'm just gathering them up in a pile. Here's a y squared. There's not another y squared. Okay, here's just a y. And then all that leaves is the constant minus 20. Okay, to multiply polynomials, just multiply every term in the first polynomial by every term in the second polynomial. So 4n squared times 5n cubed is 20 what? N to the fifth. 4n squared times 8n squared is 32 n to the fourth. 4n squared times negative 3n is negative 12 n cubed. And 4n squared times negative 2, negative 8 n squared. Okay, now I'm just going to jump over and multiply the 3 times everything. So 3 times 5n cubed is 15n cubed. I'm going to run out of room, so we'll have to take 2 rows here. 3 times 8 is 24n squared. So sorry about this. Not the best of methods. Negative 9n. And negative 6. Okay, so is there another n to the fifth? No. Is there another n to the fourth? No. Is there another n cubed? Yes. 15n cubed minus 12n cubed plus 3 of those n cubed things. Is there another n squared? Yes. 24 of them, take away 8 of them, 16 of them. Okay, is there another just n? No. And so that just leaves the constant negative 6. Okay. Okay. We also have something called FOIL. This isn't anything extra I need to learn, but you'll probably hear your teacher say it. So you need to know what it means. It's just a way to multiply 2 binomials, but it only works on 2 binomials. But look at this. It's not anything different. This says use FOIL. FOIL, well, I think they were just telling you that, so let's just back up so I don't have to rewrite it. FOIL, well, they don't do a very good job of telling you that, stands for FOIL. So this stands for first, outer, inner, last. Right? FOIL. First, outer, inner, last. And it tells you multiply the first terms in each binomial. So y times 3y, 3y squared. And then the outer terms, right? So the outside ones, so negative 2y. Then the inside ones, negative 12y. And then the last ones. It's the same thing we were just doing, right? Multiply this times this, and then go across. And then once I've multiplied the y times both of them, jump to the negative 4 and multiply it times both of them. So I don't need this. But a lot of times instructors or instructions and instructors will just say, okay, FOIL this. It only works on 2 binomials though. So if this is the only thing you memorize about how to multiply polynomials, when you get to a trinomial, times maybe a polynomial with 4 terms, you're like, how do I do that? And you think, I can't do it because FOIL doesn't work. So be careful about relying too heavily on just knowing FOIL. Instead, I'm always just going to do our distributive property. Now I might use the term FOIL just to mean multiply those binomials, but as far as the process, no, I'm going to just do like multiplying any size polynomial times any size other polynomial. Now don't forget, we got to combine like terms before we are finished. So really this is negative 14y plus 8. Okay, so I'm multiplying two binomials, so I could think about FOIL, but I don't need to. It's just the first term times both of these, so 5n squared, and then plus n, and then the last term times both of these, so negative 35n minus 7. If there are any like terms, be sure you combine them. So 35n's plus 1n, negative 34n. I think I said just 35, but negative 35n's plus 1, right? Be negative 34. Okay, multiplying two binomials again. So 3g times 9g, 3 times 9 is 27. G times g is g squared. 3g times 4, negative 4. 3 times negative 4 is negative 12, and then just times g. Okay, I've multiplied the 3g times both terms. Let's move to the 2. 2 times 9 is 18 times g. 2 times negative 4 is negative 8. Anytime you have like terms, we need to combine those. So negative 12g plus 18g, 18g's take away 12g's, leaves you 6g's. Okay, and then minus 8. Okay. Six times 4 is 24. A times a squared. 6 times negative 2 is negative 12. A times b is just a times b, right? 3b times 4a. 3 times 4 is 12. And a times b is ab. 3 times negative 2 is negative 6. B times b is b squared. Okay. Oh, now we got a plus 12ab minus 12ab. So really, we have 24a squared minus 6b squared. All right, one more time. A trinomial times a trinomial. Now notice FOIL would not work here, but it doesn't matter. All I'm going to do is multiply every one of these terms by every one of those. Let's start with the 5x squared. 5x squared times x squared. 5x to the 4th. Okay. 5x squared times negative 3x. 5 times negative 3, negative 15. X squared times x would be 3x's all multiplied together. 5x squared times 5, so 25x squared. Once I've multiplied every one of these terms by the 5x squared, move to the 2x. So 2x times x squared is 2x cubed. Okay. 2x times negative 3x, negative 6x squared. And 2x times 5 is plus 10x. Now that I've multiplied that term times every one of these, move to the next one. 1 times x squared, oh, that's just x squared. 1 times negative 3x negative 3x. 1 times 5 plus 5. Okay, and now that I've got it all multiplied out, just see if there are any like terms I can combine. Any other thing that's next to the fourth? Nope. So I've got 5 x to the fourth. Any more x cubes? Yeah. Any more? Nope. Okay, negative 15 plus 2, negative 13 x cubed. Any more x squared? Yep. Any more? Yep. Okay, so 25 minus 6. So that's 19x squared. And add one more, so now 20x squared. Okay, I'm to the just plain x's. And here's just an x. So 10 of them minus 3 of them is 7 of those x's. And then all that's left is the plus 5. And notice I can tell at a glance I've accounted for all my terms. Okay, multiplying polynomials. Let me know.